So we have learned how to solve linear systems with matrices. However, we will now learn how to solve linear systems with inverse matrices. So first we learned it. It was a little bit hard with Cramer's rule, as you might recall. And now I think this one is a little bit easier, but we will use the concept that we just learned in the previous video of inverse matrices. So let's say that you have the following systems of equations. So ax plus by is equal to e, and cx plus dy is equal to f. Using inverse matrices, we'll be able to solve this. However, let's just see how this looks. So by having that those equations, we're actually saying the same thing as I'm putting right here. If you already know how to multiply matrices, which you should know based on the previous videos, you should also know what this means. So, if you were to multiply these matrices just like we did before, doing the first column times the row, and then our second row times the column, you will find out that you actually get these systems of equations above. So you have your first element right here times your first element of the column, so that's ax, and then you add it to the second element of the row times the second element of the column, by, and here we have the equal sign, so we know that the product of this matrix should be equal to this one, and so we know that our result, whatever we multiply the first row times the first column right here, would be found in our first row, first column, and whatever we multiply and whatever we find to be the result of the second row times the first column should be found in the second row, first column. So if that's the case, we find that this right here, a times x plus b times y, should be equal to this top portion right here, should be equal to e, and same thing for the bottom. So cx plus dy should be equal to f, and we find out that this is exactly the same. So we're just rewriting our systems of equations into matrices, not changing anything. We're not doing anything kind of weird. We're just rewriting it. And so now the way we find the answer. So if we have this now this multiplication of matrices, which is equal to another matrix, we could just multiply both sides. If this was A, we can multiply both sides by the inverse of A, and we would get the result for x and y, their values. But remember that multiplying a times b is not the same thing as multiplying b times a. So for example here, since we are multiplying the inverse of a to the front of this of these two matrices right here, we want to also multiply the inverse of a to the front of this matrix. Multiply a to the negative 1 times ef. If we were to place the a to the negative 1 right here, it wouldn't be the same. So make sure that if you put this to the left, you want to also have it to the left of ef. So that's something very important to keep in mind. But now that we have that clear, we find out that this is just a to the negative 1 times a, which we found out in the previous video is just the identity matrix. So we have the identity matrix times xy is equal to the inverse of a times ef. The identity matrix is basically like having a 1 in front, so if you have 1x, we know that that is equal just to x. So we can actually just erase it from here, and we find that we can get the result. We can solve for x and y just by multiplying both sides by the inverse of a.